Hi, I'm Andrea and welcome to Productive C Sharp. In this video, I'm going to talk about list patterns introduced in C Sharp 11. I have a simple console application targeting .NET 7 and C Sharp 11. I have a numbers array, a switch expression that try to match on that arrays and then print the match to the console. So I'm going to show you using this switch expression all the kind of list patterns that you can now use in C Sharp 11. Let's start from the simple kind of list pattern that is the empty match. You can use open and close square brackets to indicate that you want to match an empty array. So if you do that and you run this code, you can see that this is printing empty array because this pattern is matching the numbers array that is currently empty. Okay, pretty straightforward. The next kind of list pattern you can use is the exact match. You can exactly list the kind of elements you want to match. Let's say you want to match all the numbers, all the numbers arrays that includes 1 and 2, and this is going to match 1 and 2. Obviously, if I run this code, it's going to still say empty array because obviously is match. But if I change the elements to include 1 and 2, for example, and I run this code, now it's going to match 1 and 2. Okay, this is a kind of constant list pattern using an exact match. If you want, you can use obviously other kind of pattern match, other kind of patterns that are present in C# to like relational patterns or logical patterns to actually match on a condition. Okay, so let's say I want to match all the elements that are 1 or 2 as the first element. I also want to match as a second element all the things that are, I don't know, greater than 5. Okay, and now I'm going to say that I'm matching this list pattern. So now I'm using the list pattern, but inside each of the elements, I'm not using a constant pattern, but I'm using a relational or a logical pattern or any other pattern supported by C#. If I run this code, still matching 1 and 2 because this pattern is matched. But if I change, for example, this 2 to be a 5, no, let's say 6 need to be greater than 5. Now it's going to match all the lists that are, 1 or 2 as the first element and the second element greater than 5. That's actually quite nice. But what if I don't care about the last element, for example? I can still use the discard patterns and do underscore. Let's say I want to do, instead of greater than 5, I'm going to do underscore. Okay. Now, this still match because underscore is effectively discarding the second element. I don't care what's the value of the second element of the list. The next patterns that also you often want to use when you do list patterns is the var pattern. You want to actually capture the variable sometimes. So let's say I want to capture the first value and then underscore. So match first, and I want to print the first. Okay, let's say I want to match the first element of the sequence. If I run this, obviously still matching this one, so I need to change this to be, let's say, 3, so that the third pattern doesn't no longer match. And now it's matching the new pattern I created, that capturing the first element of the array and printing it. So pretty straightforward. You can capture variables, even in list patterns. That's great. But what if I have, for example, a lot of values here, right? And I want to still capture the first element. Obviously, you could actually add as many underscores as you want, but you don't really have much power here in terms of flexibility. Well, Microsoft introduced what is called a slice pattern. I can use the dot notation to say match 0 or more elements from here and forward. So this new pattern here is matching all the arrays, capturing the first element, and regardless of what the number of other elements are present in this list, this will match. So if I run this code, it still say match first 3. I can actually print the value of the rest by capturing the slice pattern. So I can do var rest, for example, and then I can do like string join, and then I'm gonna kind of comma separate the rest of the values. If I run this, it's going to say, okay, I matched the first is 3, and then 6, 6, 3, 2 are the rest of the elements because it's is matching any of the remaining elements. So the slice pattern is quite powerful. You can really do a lot of powerful stuff, and taking any slice in the middle of the list. It can be either at the beginning, in the middle, or at the end of the list pattern. And this is pretty much the kind of combination you can do with list patterns, and they provide quite a flexible way to pattern match against lists. That's something that wasn't possible until C# 11. But how can you use this feature? So when can you use this feature? You can use it with arrays and list, or any types that is countable and indexable. Okay, you can't use it with IEnumerables, right? So if I make this an IEnumerable of int, for example, right, that obviously an array implements, the list pattern doesn't work because the compiler doesn't know, how to count, how to get the number of elements, or how to index an element. Okay, so this only works for arrays and iList and any countable and indexable types. And that's what I want to show you now. So if you have your own type, you can still use this feature because the compiler is using kind of duck typing in order to translate the list pattern into normal, if statement and method calls. So let me introduce a class that I called numbers. And this class is fairly simple. It's just simply encapsulating an array. Okay. If I replace these numbers to use the new numbers class, all right. So see what happened. The compiler obviously is not happy because this class does not expose anything that helps the compiler to know that this is a countable or an indexable type. So you need to expose some of this information to have the list patterns to work with your own type. All right. So the first things you need to do is to expose the count. So let me use the count method to actually expose the count. This could be either a count or the length method. So if you see, the compiler error is saying, okay, list pattern may not be used for a value type numbers. No suitable item indexer was found. An indexer is also necessary in order to use this feature. So we can use an indexer. So basically, is a property that takes the index and return the element on that index. Now the compiler is happy for all the top 3 list patterns. So let me comment this out for now. So because if I build this actually compile. Now by exposing the count and exposing the index, now I made my type countable and indexable. That means I can use all the list pattern matching functionality I have except the slicing functionalities. So if I run this, it will say no match. Okay. So what if I want to also have the slicing functionality available? As you can see, the compiler is looking for a slice method or a range indexer. So the range indexer looks like that. You need to take a range and then return basically the slice that the compiler is looking for. And now this compile and run as expected. Okay, that's very interesting. So if you want, you can add all the 6 methods just for completeness. So the compiler is looking for length or count to know that your type is countable. Is looking for an indexer that takes an int or an index to make the type indexable, and is looking for a range indexer or a slice method that takes the start and the length to actually support slice pattern in list patterns. Okay, so if your type satisfies these conditions, you can use your type. You can use the list patterns to match against your type. There's another final things I want to show you, that is the ability to nest list patterns. So list patterns can be nested. So if you have a more complex type like an arrays of arrays, and I'm going to copy something in. Let's say I have a matrix here. So I need to do it above the type here. Let's say I have a matrix here. This is basically an array of arrays. And I want to capture the center element of the matrix. Of course, in this case, you wouldn't use like this sophistication I'm going to show you. But just for training purposes, I want to show you that this is possible. So let's say I'm going to do something like this. This is a nested list pattern. So as you can see, there is a list pattern in the middle that is matching against the middle row of the matrix. We are kind of discarding the first and the last row of the matrix. And then we're using a list pattern to discard the first element and the last element of the middle row and just capture the center variable. So you can list as much as you want all patterns. It's something that the C# compiler support to have, to support this sort of advanced scenarios where you want to match an array of arrays, for example. This doesn't work with two-dimensional arrays, for example. Only works with jogged arrays or nested list. Okay. So something for you to consider as well. So if I run this code, you would see that it's printing 4. That is the middle element of the matrix. So I think this is everything I wanted to show you. There's one final thing. If you're really, really curious, you can actually go deep and see what the compiler does under the covers to translate the switch expression into your own code. It's not something that you really need to know, but just for you to, if you're curious, the compiler is actually using the countable property, the length of count, to check against the length of the list, and then based on the length is, get into a different particular path. Okay, so if it's match 0, it's also an empty match. If match 2 checks that is matching, the 1 and is matching the second element to be 2 and so on. So it's basically using a chain of if statement or switch statement to check the exact matches. And more importantly here, you can see that it's actually calling the range indexer when you try to do some slicing. Okay, not that you need to go into much depth. This code can be quite hard to read, but the benefit is that you don't need to worry about that. You just use very nice simple syntax to pattern match against list that is very, very functional. This is kind of a functionalities that the C# is now exposing that are quite common in functional languages. So I would always, as usual, recommend not to use the feature when the code doesn't look good or is not readable. Like this one, I would really argue against. So always use the features to make your code more readable, more compact, and I think it's a very, very nice feature, something that was missing in the pattern matching story of C#, and now C# 11 support list patterns, and that's something I would encourage you to use in your projects. Thank you very much for watching, and see you next time.